Welcome to this introduction to Acta. To show the possibilities of the library, I will build a to-do list in React, TypeScript and Acta. The complete documentation is available on acta.js.org. The application code is available in the example-app folder of the library repository and GitHub. This is a link in the description. To initialize the application, I'm going to use create React app. This is a command line tool that writes all the scaffolding for you. Go to their website for more information. To start, they advise to use npx. npx is a command line tool shipped with npm that allows you to use npm modules without having them on your machine. To start, I use the TypeScript template and paste the command they give in the terminal. My app is going to be Acta test. Then I open Visual Studio Code and add the Acta package with Yarn. I also add the SCSS support because I find it more convenient for styling. For this, I just need to add Node.sass. Then I can call yarn run start and the dev server is now started. I remove all the stuff that I don't use and rename the styles to SCSS. In the app.tsx file, I remove the content and add the main tag with a header, h1 and Acta example application for the title. And it does not work because we are trying to load an CSS file somewhere. It is still not working because apparently Node.sass is incompatible with our script. So let's go back to version 4. It still calls an index.css. Let's change that. For this video, I am going to build the application simultaneously in a component classification and in a functional classification. When it's underlined like that, it's often because we have something in the cache. Just reload the workspace. It is still not working properly because we have an error in the tsconfig.json file. Let's fix it and we are good to go. I am not a big fan of the default imports and I favor named imports. I find it more practical and it generates less error. Before starting coding, let's write a small style reset. Box hiding in border box is super important because it forces consistency between borders, padding, and margin. I put the padding and the margin to 0. I set the font to inherit to avoid having components managed by the browser with a font that is not consistent with their container. In app.tsx, I import our future components in a div with the ID to-do list. I add my functional to-do list and class to-do list. Since these components do not exist, it breaks the application. So let's create them. In our component folders, I add the functional to-do list.tsx file. Note that the import React is not necessary since React 17, and then I export our little component, a constant because this is a functional component. At the moment, this is a simple div in which I just put to-do list. I do the same thing for the to-do list class component and export class to-do list. I've been asked, why do you have to type everything like this? TypeScript compiler can infer the fact that the render function will return a JSX.element. The compiler can infer many things, but when you tell him what he should expect, it does not have to do it, meaning that there is less work to be done for the compiler. Obviously, on a micro project like this one, with 10 files, it's not a problem. But on a large project, you will feel it at the build time and even during development. So I prefer typing everything. I import the components in the app.tsx file to fix the application. We have now our little class to-do list and our little functional to-do list. Let's start with the function. I add a little title with an h2 that says functional to-do list. Before I start on that, I like to write typings for my shared object. So I create a types.ts file at the root of the application. Normally, I would put it in a type folder. I export an i2do interface that contains a label with a string type and a date that we will put in a timestamp. So it's going to be a number. In the functional to-do list, I start by display what happened when there are no to-dos. Just a text that says no to do yet. Add one to start. Now I initialize the to-do array used internally to store the to-dos. So if we have no to-dos or that we have 0 to-dos, the message will be displayed. This table of to-dos comes from Acta. We retrieve the value from the acta.useActaState hook. It takes the value of the to-do list in the Acta states and return an empty array if nothing is found. To help the compiler, I tell it that it is supposed to be an array of to-do. I do not advise you to use magic strings like that when you are using shared keys for Acta. What I do in general is that I will write shared enum. So I create a constant file, actakeys.ts, and there I export my key, Acta state to do. You can also use TypeScript enum. They don't get too much love today, but I still like them. Sometimes you need to reload your VS Code workspace to force it to index everything. It's convenient to get the auto-import features with the autocomplete shortcut. Now the components are subscribed to the Acta state to-do state in Acta. It means that every time that Acta.setState is called somewhere in the application, the value of to-do will be updated and the component will re-render. Because Acta is globally available, if I go to the console and that I type acta.setState with that key and that I pass an array with an object containing a label hello and a date 123, the message saying that there is no to-do disappears. I can now add a map on the internal to-do array to display the element. The map returns to-do items that need the key. You can see that because we typed our to-do elements, the autocomplete features of VS Code tell me what I can find inside, a label and a date. In a real application, I would generate a unique ID, but for this one, I consider the date to be unique. Inside, I had a span in which I put the to-do.label. And I put the date with a new date.toLocalDate string to have something pretty. It worked. We can see that our little to-do is displayed. The date is 1970 because we are 123 milliseconds after January 1, 1970. If I want to erase them, I pass an empty table. Next step is creating action. The first action will be to add a to-do and the second, delete one. I create an action file which will be add-todo.ts in an actions folder. This action is a function that takes as parameter an object containing a label and a date. It calls acta.setState with the key acta_state_to_do and makes a spread on acta.getState of acta_state_to_do. Then I create the action to delete a to-do in delete-todo.ts. It is more or less the same as the add function, but with a filter. I get the current array of to-do in the state, filter to remove the to-dos with the same date, and set the result in the state. In the interface, I add a button to trigger the delete on its onClick attribute, and I pass the target to-do as a parameter. And I forgot to rename the function. I can now remove the to-do from the interface. Let's now build a form to add a to-do. I start by adding this add to-do form in the app.tsx file, which breaks the application. Now I create the add to-do form.tsx file and export the form. The form contains a text input with a placeholder to-do label and a submit input with the value add to-do. The onSubmit attribute of the form triggers a private onSubmit method, starting with an event.preventDefault to prevent a page reload. The event is a react.form event with a HTML form element target. Then I retrieve the label from the value of event.currentTargetElements at 0 as an HTML input element. You have to specify that it is an input element to the compiler. If the label is falsy, stop there. Don't forget to trim the label to remove spaces before and after. I can now call my action add to do with a label and a new date.getTime. Don't forget to reset the form after submit. When I add to-dos, they disappear on page reload. To make them persist, in add to do, I add a small parameter to say where they should be saved. We will save them in the local storage. I do the same for the delete to do. Now, when I add a to do and reload my page, it is still there. But even more interesting, it is on all the other pages. And when I delete it, it is automatically shared between the windows and between tabs. This is rather interesting when you are in an e-commerce website, for example. If you have a basket, when you update it in one of the windows or tabs, you want it to be updated everywhere. And for any application, if you log out of a tab, you want to log out of everywhere. Now that we saw how to add things in the state, remove things from the state, and make it persistent from a functional component, let's do the same from a class component. I'm going to keep roughly the same template. For the class to-do-list.tsx file, I'll start by typing the state. I like to make an interface for my states that I always call iState. I also have an iProps interface when needed. The key to do is an array of I-to-do. I won't use props here, so I write unknown. I initialize the public state with an empty to-do array. I could have made it optional to avoid having to initialize it, but now I'm sure that it is an empty array. I get the to-dos from this.state, and I don't forget to type the state. I subscribe to the Acta state in the component.mount method. You should almost always subscribe from there. In Acta subscribe states, I pass the global Acta state to-do key, the local to-do key, and this as the context. Subscribe state will subscribe to a global Acta key, and every time it is modified, it will call a this.set state, passing the value of the state in Acta to the selected key in the local state. You can also have something a little more complicated with a callback. If you have things to do when you retrieve the data that are a little bit heavy to process, you can use the callback and process the data here. Now, the class to-do list and the functional to-do list components behave the same way. The to-dos are injected in both components simultaneously. The styling phase is not super interesting, so let's fast forward to the events management. You can get the style from the application in the repo if needed. This is the second main feature of Acta. Acta states are for persistent and shared data that concern the entire application and need to be consistent everywhere. For instance, the list of to-dos. In the other ends, there are things that are just local states for which we want to have a messaging system coming from anywhere in the application. This is something that, in my opinion, is often lacking from most data manager. In app.tsx, I add two components, functional app messages and class app messages. They are going to subscribe to Acta events to inject messages in a list of messages in the local state. As we have an interface called I-to-do, I create an iMessage interface, which contains a message of type string and a date of type number. In this functional component, I initialize an array of messages to an empty array. And inside this component, I use a useState hook that returns a tuple of the internal messages and a method to set those messages. Then I use the custom Acta hook, use Acta events to set the internal messages with the set internal messages method from the React useState hook. As previously, I export an Acta event message constant from my Acta keys constant file. In the hook, I set the event key and the callback. The callback parameter is the message that was dispatched. I can now create and inject a new message with message and a date as newDate.getTime in the static messages array. Don't forget to type your data to help your compiler and import the constants. I can now map the internal messages in a template to an array of divs containing the messages. Then I use the setInternalMessages method written by the React useState hook. You cannot just pass again the static array. It would not trigger a re-renders. React hooks are built with an immutable way of thinking. When you push data in an array, you don't change the reference to this array, so the actual value of the static message does not change. I know, why isn't there a second parameter that we can pass to true to false re-render? Well, this is a React internals issue. To see the update, you need to return a new array. You can do this by using the slice method or simply with a spread. In the console, I enter acta.dispatchEvent with the key Acta event message, and we can see the message. I need to make it disappear after some time, so I create a message component with an iProps interface containing a string message and a serve close function. After a certain amount of time, the message will self-destroy by calling its parent to delete itself from the parent local state. I insert the message and the call to the closing method in the body of the function after a 1.5 second delay. I replace my div by the new component in the parent. Do not use a date as a key in your real-world applications. They may not be unique and it may crash your application. The self-close function calls a private method delete internal message. This function takes a date as parameter and uses the set internal messages method to set a filtered version of the messages in the local state. I fix a typo in the message component and we can now see our messages appear and disappear in the interface. Now I can do the same thing in the class app messages component. The iState interface contains an array of iMessage and I initialize it as an empty array. I paste the template from the functional component and the internal delete message method, except that it calls a setState instead of a custom hook method. Then I subscribe the component to the Acta event, the key Acta event message with Acta subscribe events, and when it catches a message here, it sends it to a callback. Do not forget to pass the context. In the callback, I add a this.setState to inject the newly received message. So now, when I dispatch this event, the message appears twice, once in the functional component and once in the class component. It does not disappear because I made a mistake in my filter, so I fix it. When I dispatch this event, I can only see the result in this window. As for Acta states, you can share messages between windows and tabs. Set the second parameter to true to dispatch the event across tabs. Once again, I will fast forward the styling process and the addition of a form to dispatch messages from the interface. The result is a non-checkable to-do list with messaging capabilities synchronized between tabs, functional and class components built with React, TypeScript, and Acta. It's important to have a state that is easy to manage and easy to understand. In the ecosystem, we have powerful state management tools like Redux and Mobex, but the tooling around them has a tendency to lead people into doing overcomplicated things with multiple reducers, map to props, actions, providers, multiple source, higher order components, and so on. Things that will reduce the next person's ability to understand the data flow. And if you cannot understand your data flow instantly today, it means that 3 months from now, you will be lost in the layers of abstraction that you just created and that any modification will be a nightmare. Here, the data flow is extremely simple and the reality is that we don't need more 90% of the time. We subscribe to Acta state to-do state, the value is injected in the local to-do state, and that's all there is. We subscribe here and we use just after, so you won't ever get lost in your data flow. Obviously, we will find ourselves creating actions and other abstraction layers at some point, but the more you decrease the number of layers, the more obvious the data flow becomes, and the more you increase maintainability, because you are sure that you are not breaking something when you're not working. The second big advantage is the absence of provider. In most state management tools, we need a provider system, and properties are dripping from it. Here, the provider is the component itself. It is responsible for subscribing and getting its own data. It is easy to decouple. If we take this component there and we put it somewhere else outside of a provider, in a portal, anywhere, it will work instantly. This is a very important part of simplifying the data flow. The tooling, the debugging, and the configuration are also simple. There is no store to configure, no access to create, no required extension to see what's happening in the store or to manipulate it. The only store is acta.states and you can access it in the global object. It should also lead you to put less things in the state. Most of the states of an application should derive from its URL. So that's it for this little tutorial. I hope that you've enjoyed it and that you will give it a try to Acta to manage your data flows and your application state.